Good morning, everybody. We are going to be continuing and hopefully finishing 4B today, logarithm and logarithmic functions. So if we look at our learning targets, we've already learned how to evaluate logarithms, and we have already learned how to change between exponential and logarithmic form. So the last learning target is to graph logarithmic functions. So we have seen logarithmic expressions, and we've also seen logarithmic equations, and now we are going to talk about logarithmic functions. So a function, remember, has an input and output. So a logarithmic function is a function in the form f of x equals log base b of x. So this is not the easiest type of function to graph by hand because it's not really easy to make a table of values. So we're going to do this in a little bit different way to see what the graph looks like. We're going to find the inverse function of f of x equals log base 2 of x. So we found inverse functions back in Unit 2 last semester, right before Christmas break. So hopefully we remember this a little bit. So an inverse function, first thing I'm going to do is instead of f of x, I'm going to write that with y equals. So y equals log base 2 of x. Then the thing that makes a function an inverse is that we're going to switch x and y. So instead of having y equals log base 2 of x, I'm going to have x equals log base 2 of y. Then, after we switch x and y, the goal is to solve for y or get the y by itself. Because even though this is technically the inverse, in function notation, we have the output by itself. Okay, now, somehow I have to get this y by itself. But right now, we're taking a logarithm of y, log base 2 of y. So the way I can rewrite this is this is in logarithmic form. This is log base b of a. I can change to exponential form. So logarithmic form, this is in the form log base b of a equals p. So this side is the p. If I change to exponential form, remember it's going to be b to the p power equals a. So that would be, the base is 2, so it would be 2 to the x power equals y. Okay, now the y is by itself. So this is my equation. Y equals 2 to the x power. Or remember, the inverse notation would be f inverse of x. That's the f with the little -1. F inverse of x equals 2 to the x power. All right, so here is what's really important to notice is that this logarithmic function and this exponential function with the same base, so that is important that they both have the same base of 2, but notice they are inverses of each other. That means if we can graph the exponential function, which we already know how, then we'll be able to use inverse functions to graph the logarithmic function, and that's going to be much, much easier. So let's graph. So as we just saw, logarithmic functions and exponential functions are inverses of each other. So f of x equals log base b of x, and g of x equal to b to the x power are inverse functions. So if we can graph one, we can graph the other by just switching the inputs and outputs. All right, so we're going to graph f of x equals 2 to the x power and g of x equals log base 2 of x on the same coordinate plane. All right, let's make a table. Well, not really a table, but let's find some coordinate points on this function. So f of x equals 2 to the x power. This one is easy just to plug in values of x. So I'm going to use -1, 0, and 1 for my x values. We're just picking those. And when we plug them in, the first point would be 2 to the -1 power. And remember, a negative exponent is a fraction, so that would be 1/2. Next, I'd plug in a 0, so 2 to the 0 power is 1. And if I plug in a 1, 2 to the 1 power is 2. Okay, so these are points on my exponential function. And then one thing to remember on these is they have an asymptote, a horizontal asymptote at y equals 0. So let's go ahead and graph this. So my asymptotes at y equals 0 that is a horizontal line. Then I have points at -1, 1/2, 0, 1, and 1, 2. And then remember our exponential function looks like this. It's close to the asymptote as we go towards the left, and then it's increasing exponentially as we go to the right. All right, now here is what we're going to do to get our logarithmic function. Get our logarithmic function, g of x. Rather than trying to plug in numbers for this, g of x equals log base 2 of x, rather than picking -1, 0, and 1 and trying to plug those in, I would have a problem if I just tried to plug those in because we might remember we saw we can't actually plug in a negative. So if I tried to do a logarithm of -1, that's a logarithm of 1. If I try to do a logarithm of -1, it says an invalid output. Same thing if I try to do a logarithm of 0. So I can't actually plug in a -1 or a 0. So instead, what we're going to do is we're going to use the fact that we have inverse functions. So the thing to remember about inverse functions is that if the original has xy, to get a point on the inverse function, we switch the x and the y, and we would have yx. That means on this logarithmic function, instead of the point -1, 1/2, I'd have the point 1/2, -1. Instead of the point 0, 1, I'd have the point 1, 0. And instead of the point 1, 2, I'd have the point 2, 1. So we're just switching the x and the y values, not the positive or negative signs, just switching the position. Okay, now what's going to happen on a logarithmic function? Since we can't plug in a 0 or a 1 for x, this is going to have a vertical asymptote at x equals 0. All right, so let's see what this graph looks like now. Let me get a line for our asymptote. So this time the line is a vertical line. So a logarithmic function has a vertical asymptote at x equals 0. And then our points, we have a point at 1/2, -1, 1, 0, and 2, 1. Okay, so the graph is going to be close to the asymptote as x is close to 0, so going down, and then it's going to curve off to the right like this. So it's still increasing, it's just increasing very slowly. All right, so the one in blue is our exponential, and then this one in purple here is our logarithmic function. So in general, this is what our logarithmic functions look like, and these are the types of points we have. So rather than taking numbers and plugging them in like we did here, we are going to have to recognize what the pattern of these look like so that we can figure out what our graph looks like. So a logarithmic function, we're just going to summarize a few things about a logarithmic function. A logarithmic function is in the form f of x equals log base 2, or sorry, it can be any base, not just base 2, log base b of x. So the points on this function, as we saw, it's going to have the point 1 over b, -1. It's going to have the point 1, 0. And it's going to have the point b1. So the b is just coming from the base. And these 3 points are coming from the inverse of the exponential function. Now this one, as we said, has a vertical asymptote. And so our vertical asymptote is at x equals 0. So in general, our graphs look like this. As we said, they have a vertical asymptote this time. And they're going to look like this curved shape here. Another thing to notice about this, let's talk about our domain and range of this. The domain here, we can't plug in anything we want for x. We can't plug in zeros or negatives. So our domain, the furthest left is 0, but it's never actually equal to 0. And the furthest right is infinity. So our domain is 0 to infinity. And our range, the lowest to the highest, it keeps going infinitely down and it keeps going infinitely up. So our range is negative infinity to infinity. And then this is an increasing function because it's going up as we go from left to right. All right, so that's our logarithmic function. Now, just like we did with exponential functions, we can graph logarithmic functions using transformations, which is what we're going to do on these examples here. All right, so the first example, we're trying to graph f of x equals log base 3 of x plus 4 minus 2. So this is a parent function that's been shifted. Notice the plus 4 is in the parentheses with the x, so that's actually shifting it to the left 4. And then the minus 2 is shifting the graph down 2. So we are taking the original parent function, which is going to look something like this, and we are shifting it. All right, so that means like anytime we're graphing with transformation, we start with the parent function. Parent function would just be log base 3 of x. So it wouldn't have the plus 4 or the minus 2. F of x equals log base 3 of x would be our parent function. So our points on our parent function are going to be in this form: 1 over b negative 1, 1, 0, and b 1. And our base is 3. So that means my first point is going to be 1 over 3, negative 1, 1, 0, and then 3, 1. Okay. I'm not going to worry so much about the one with the fraction. I can, as long as I know the shape of this, I can still do this with these 2 points. So I'm just going to use 1, 0, and 3, 1. So instead of 1, 0, and b, we're using 3 as the base. So these are the 2 points I'm going to use. And then we also have an asymptote of x equals 0. Let me make some room to fill that in. Okay. So our asymptote is x equals 0. So this one only has 2 transformations. We've got this plus 4 that's with the x. So I know that's affecting the x value. Now remember, when something's with the x value, we do the opposite. So to do this operation, we are actually going to subtract 4 from the x values. So that means I'm going to subtract 4 from the x values. However, notice our asymptote is also x equals, not y equals like exponential. This one's x equals. So I'm also subtracting 4 from the asymptote because it's an x value. So now my new points, my new x values are negative 3 and negative 1. And so far, I haven't changed my y values. So my y values are 0 and 1. And then my asymptote now is x equals -4 because we subtracted 4 from that as well. All right, and then the other one more operation is this -2. It's not in the parentheses, so it's not part of the x. It's on the outside of the function. So the -2 there is affecting the y. So for that, we're going to subtract 2 from the y value. So I'm subtracting 2 from the y values, not the asymptote this time, because the asymptote is x. All right, so my x values were -3 and -1. Now my new y values are -2 and -1. And my asymptote hasn't changed from the previous step, so it's x equals -4. All right, so that means these are my final points here and my final asymptote that I am going to graph. Okay, so my asymptote is x equals -4. Don't forget that this is a vertical line. So when we draw that in, it's crossing the x-axis at -4, and we're drawing it in as a vertical line. And then I have points at -3, -2, and -1, -1. Okay. So I know I only drew 2 points here, but since we know what this graph looks like and we have the asymptote drawn in, we can draw in this graph. The graph is going to be close to this asymptote until it gets to these points, and then it's going to turn and curve off to the right side like this. So that's what our graph of this function looks like. It has been shifted to the left 4 and down 2. All right, let's do one more. So this one we have log base 5 of x minus 2 plus 3. So same thing, we're going to graph using a parent function and then transformations. So the parent function is f of x equals log base 5 of x. So our coordinate points, I'm not going to use the one with the fraction. I'm just going to use these two. So we don't have to make it a little easier on ourselves and not have to deal with the fractions, I'm going to use the 2 points with the whole numbers. So my points that I'm using 1, 0. And this time the base is 5, so the other point is 5, 1. And my asymptote is x equals 0. So remember, vertical line, so it's x equals. All right, now let's do our transformations. So our first transformation we do is what's with the x. This now has a -2 with the x, so that's going to shift to the right 2. So that means we need to add 2 to the x. I'm going to add 2 the x values, including the asymptote, because the asymptote is x equals 0. So my new x values are 3, and the y value is still 0. And then this new x value is 7, and the y value is still 1. So those are my points. And then my new asymptote is x equals 2. And then one more transformation. We still have this +3 here. The +3 is on the outside, so it's affecting the y values. With the y's, we just do the operation we see. So for this one, we're going to add 3 to the y values. Okay. Notice I'm not adding it to the asymptote because the asymptote is not y equals. All right, so now my new points. This point becomes 3, 3, and this point becomes 7, 4, and my asymptote is still x equals 2. And these are the points that we're going to graph here. So my final asymptote is x equals 2. And remember, that is a vertical line. The most common mistake is people draw it in as a horizontal line. So make sure on logarithmic functions, we are going to x equals 2, and then we're drawing in a vertical line. Okay, so there's our vertical asymptote. And then let's plot our points. 3, 3 is here. No, it's not. Let me regraph that. 3, 3 is here. We're going right 3 and up 3 from the origin. And then 7, 4, so right 7 and up 4. And then we draw in our asymptote. This is going to be very close to the asymptote right here. And then it's going to curve to the side like that. So notice all these graphs look very similar. They're, again, just shifted in different directions. This one is shifted to the right 2 and up. So same types of transformations we've been doing, different starting function. So on a logarithmic function, with whatever the base is, it's going to have these points and a vertical asymptote. And then we just do our transformations, and from there we can graph. All right, so we have finished up for B, and we'll be able to do more practice with the graphing tomorrow.